In this question we've got to sketch the graph of y equals 5 cos 2 times x minus pi on 3 for x within the domain of minus pi to plus pi inclusive. Well guys, this would be an exam 1 style question because these kind of things just don't come up in exam 2 anymore because you have the CAS technology available to you, which makes it a fairly trivial exercise. Now, having said that, even in exam 1 they don't come up that often because they're tedious and annoying, pardon me saying that, and they take quite a while to do because of their tedium and the steps involved. However, that doesn't mean we shouldn't learn how to do it because they could come up and we have to be prepared, alright? Now, it's an average style question, this one, probably about the right level for an exam 1 question. We have to size it up now and we have to work out just exactly what the transformations are. And I can see at a glance that I'm very relieved that this one has not been translated vertically, that is in the y direction, because if that happens, then it makes it a lot more complicated because you cannot then tell how far the x-intercepts are going to be apart because of this movement vertically, that is for a sine or a cos graph. And therefore, because it has not been vertically translated, we can work out the x-intercepts pretty easily just by adding this translation factor onto what would normally be the intercepts of a cos graph which has not been horizontally translated, if you get what I mean. I'll show you in a moment. Anyway, now, regarding this one, what have they done to it, guys, from our base model template cos x graph? Well, we've got an amplitude of 5, so it's been stretched in the y direction by a factor of 5. We've got a period of pi. 2 pi over that number 2 is the period of this, so it's been squashed into half its normal period, and we've also got a horizontal translation of pi on 3 units to the right, so they've certainly done some surgery on it. But no problem, we can easily get at it, and we just have to follow a few steps and be systematic about it. The very first thing I would like to do is work out what happened to its natural starting point in terms of the translations they've done. For a cos graph, it would normally start where x is 0 and y is 1 at the top of its travel, wouldn't it? Okay, now in this case, what they've done to it, they've stretched it by a factor of 5 because of the amplitude, and they've moved it over to the right by pi on 3. So the starting point where we would normally start a cos graph at the top of its travel will now be x is pi on 3 and y is 5. Now that gives me some comfort because it shows me where to start the thing. And then I basically trace it in quarter cycle steps. That's how I do it. I'll show you in a moment. Right, so I need to know what a quarter cycle is. It's pi on 4, or if we're going to do twelfths, which you'll see in a moment we will need to, that'd be 3 pi on 12 steps, okay? That's used for sketching. Now, guys, if there was no horizontal translation, the x-intercepts would be, the first one would be at a quarter of a cycle, okay? Now, in this case, that would be at pi on 4, okay? That's going in the positive direction. Or then a half cycle from that point onwards, which would put it at 3 pi on 4. That's pretty easy to figure out if you just think about that. Now going backwards, because of course we've got to be worried about this in the negative as well as the positive for our domain, we would have exactly the same situation. We would have minus pi on 4 and we'd have minus 3 pi on 4 because cos, as you know, is an even function. So cos of minus x is the same as cos of x. You knew that, didn't you? Yes, of course you did. Now, I've put them in twelfths for you to make it a little bit more easy to swallow as we go ahead and tackle this question. Now, with the horizontal translation of pi on 3, that is 4 pi on 12 to the right, guys, we've got to add that amount to every one of those numbers. Okay, so we're going to get those intercepts there. I've added 4 to each of those twelfths, so it's minus 5 plus 1 plus 7 and plus 13, which, oh gasp, this one is now out of range. Now, because this one's out of range, now there's a very good chance that one will have snuck in up at this other end. So let's try and be a bit strategic about that and think what it might be. Now, how far are these apart? You see there's 6 6 units, 6 pi on 12 units apart, aren't they? So if we basically go back here and go backwards by 6 pi on 12, we'd get minus 11 pi on 12. So this one would be in, minus 11 pi on 12, this one would be out now. Let's see if that's what I did. Yes, out of range, and yes, add another x-intercept to the left. They're spaced 6 pi on 12 apart, and therefore we've got those. Now that's pretty neat, don't you think? That's our x-intercepts, all done and dusted, guys. Not so bad, but it is tedious, isn't it? Y-intercept now, and then we've got to do endpoints as well. So y-intercept is when x is 0, so let's work that out. Therefore, when x is 0, going back up here, we've got y is 5 cos of minus 2 pi on 3. That would be the same as 5 times cos of 2 pi on 3, and cos of 2 pi on 3 would be the same as negative cos of pi on 3, which I think is going to be negative a half. Yes, very good. Now the endpoints are the endpoints. All right, we've got to put x is pi and x is minus pi into this equation up here and see where we end up. So when x is minus pi, we get that. Goodness, that becomes the same as 5 cos of 8 pi on 3. Now that'll be the same as cos of 2 pi on 3. That'll be minus 5 over 2 again. Very good. And the other endpoint's going to be the same. I can see it. When x is pi, let's just go through the motions. It'll be 5 cos 4 pi on 3. Now, cos of 4 pi on 3, what's that the same as? That's the same as minus cos of pi on 3, yes. Yep, it's going to be minus 5 on 2. Are you with me? Are you getting me? Great. I think, guys, we're ready to go. Yes, we're ready to roll. Let's go over the screen now. Ooh, look at that. I've got it all done with pi on 12ths here. I've got my starting point all mapped out and ready to go, guys. Look, that's at pi on 3, which is 4 pi on 12. See, each of these little graduations are pi on 12 in the horizontal. And this guy is going to move in quarter cycle steps now. So I'm going to start from there. Now, there's the first point. You go from the top down to the central axis in the first quarter cycle step. And a quarter cycle was pi on 4, which is 3 notches horizontally. So there's the next one. That's down to the bottom of the travel. Another 3 notches to the right. And then we're going to go from there backwards to there. That's another quarter of cycle back the other way. And there's another quarter cycle, another quarter cycle, another quarter cycle, and another quarter cycle. And it looks like we're just going to be sort of a little bit overshooting here down to get down to the minus pi. So that's one endpoint. There's the other endpoint over there. So right, I think we're ready to roll now. From our starting point, I've gone forward a quarter of a cycle, another quarter of a cycle, and that's the end point. Now I'm going to go backwards by a quarter of a cycle from the starting point. And we get that one, and there's the y-intercept at minus 5 over 2, so there's our next quarter cycle, and there's our next quarter cycle, and final quarter cycle, and the leftover bit to get to the end point. And we're nearly done, guys. It's a simple matter when you do it systematically, but we do have to label everything to within an inch of its life so that we get everything right and we don't lose any marks for not annotating all the endpoints and intercepts. So that's one endpoint there. That's the other endpoint there. That's the y-intercept there. Now, we've got to put all our x-intercepts in now. Pi on 12, 7 pi on 12. Do them as coordinate points. And there's the last two. Minus 5 pi on 12 and minus 11 pi on 12. Oh, goodness, is there anything else? I think not. Oh, just to label the graph. And we are done. Yes? Very, very nice, okay? But as I said to you, it would be a whole order of magnitude more awful if the thing had been vertically translated, because we wouldn't be able to work out the x-intercepts so easily. We'd have to work them out analytically, which would be a pain. But you won't get any of those in the exams. I'm pretty confident in exam 1 where you have to do them by hand because they just take too long. Alright, I hope you got something out of it, and we'll see you soon.